Welcome to Session 5. Linear inequalities describe ranges of values, not usually one exact answer. Today we solve inequalities, handle compound statements, graph shaded regions, and use context to round correctly. The critical rule is simple but easy to miss. When you multiply or divide both sides by a negative number, reverse the inequality sign. From negative 2x is less than 6, dividing by negative 2 changes less than to greater than, so x is greater than negative 3. An inequality describes a set of values. Strict symbols use an open endpoint because the boundary is not included. Less than or equal to and greater than or equal to use a closed endpoint because equality is allowed. Compound inequalities come in two common types. An AND statement means the value must satisfy both conditions at once, so the answer is the overlap. An OR statement means either condition can work, so the graph can split into separate pieces. For a two-variable inequality, first graph the boundary line. Use a solid line when equality is included and a dashed line for strict inequalities. Then test a point, such as the origin, to decide which side to shade. Context decides how to round. At most 240 people means you cannot exceed capacity. The inequality gives G less than or equal to about 31.71. Since only complete groups are allowed, the greatest possible whole number is 31, not 32. Your turn. Solve negative 3x plus 9 is greater than or equal to 0. Pause the video and watch carefully for whether the inequality sign must flip. Subtract 9 from both sides to get negative 3x is greater than or equal to negative 9. Now divide by negative 3, so the inequality reverses. The answer is x less than or equal to 3. Session 5 Recap. Inequalities describe sets of values. Flip the sign only when multiplying or dividing by a negative. Use open or closed endpoints correctly. For compound inequalities, separate AND from OR. For graphs, draw the boundary first, then test a point. Next, we move to linear functions and modeling.